This video is dedicated for the case when all the brakes are acting simultaneously. For both the front and rear brakes are applied at the same time. This W cos theta is getting balanced by RA and RB. That equation 1 says. And now this force W sin theta plus W by G into alpha, that is the inertia force and the parallel component of the weight. This net force tries to pull down the vehicle along the slope, which now is getting balanced by the combination of these two forces, that is FF and FR. Both the front wheel frictional force and the rear wheel frictional force balances out this complete downward dragging force. So here we see that W sin theta plus W by G into alpha is equals to FF plus FR, which is equals to mu into RA plus mu into RB. Okay, now mu into RA, you can see that front brake force is mu into RA and the rear brake force is mu into RB, because mu is the coefficient of friction between the road and the tires of the wheels, and RA and RB are the reaction force at the front and rear wheels respectively. Then from this equation we can directly get the value of alpha by G. Now look here, that W sin theta plus W into alpha by G is equals to mu times RA plus RB. Now RA plus RB is equals to W cos theta from equation 1. So we're just going to put that as simple as that. So it will be mu into W cos theta, and then if we take out the weight common out of these two terms, so W and both the W's both the sides will get cancelled out, and you get sin theta plus alpha by G equals to mu into cos theta. And then just switch it over to the another side, we get alpha by G is equals to mu into cos theta minus sin theta. So now we found our value for alpha by G, that is equation 2. Okay, now we're going to take moments about B. So here you can see in this picture, this is B, and if we take the moment about B, what we get is we get RA into B. So this is RA and this distance is B, that is the wheelbase. So actually this is the B, so it acts like this way. It tries to tilt the vehicle in clockwise manner. So this thing is plus. Now W cos theta into X. W cos theta is this force and this distance is X. So W cos theta into X, this moment tries to tilt the vehicle anti-clockwise. So that's why here is the minus sign. And same for W sin theta plus W into alpha by G into H, that is this force multiplied with this distance about B tries to again tilt the vehicle in anti-clockwise manner. So here will be a minus once again. Now the whole summation is equals to 0 if the vehicle has to be in equilibrium, and that's obviously the condition for all the three cases. Now RA into B minus W cos theta minus, I took the W common, and we get sin theta plus alpha by G. Now instead of alpha by G, I directly put the value of alpha by G from equation 2, mu into cos theta minus sin theta, directly here, and both the sin theta got subtracted. So you get W into mu cos theta into H. Okay, don't think that this H is actually multiplied with this theta, it's out of that. Okay, and now we can get the value of RA. Just switch these two parts over to the another side. You get take the W common, you get X plus mu H into cos theta divided by B, and this B is just getting divided. Okay, so you can check it out. Okay, now let's just get to the equation 1. Now equation 1 says that W cos theta is equals to RA plus RB. So from this equation 1 we can get the value of RB. Just put the value of RA and subtract it from W cos theta. So this was the value of RA. Just put here and take the W common, you get 1 minus X plus mu H by B into cos theta. So that's your RB, which is W into 1 minus X plus mu H by B into cos theta. You can also write this thing in this way, that is B minus X minus mu H by B into cos theta. You can also write like this, but I find it much more convenient to do, because I will show you why I insist on this form rather than this form. Okay guys, here now you can see that here in this chart there are all the three results for three different cases: when brakes are applied on the front wheels, when it is applied on the rear wheels, and when both the brakes are applied. So this row represents both brakes, this one rear brakes and this one front brakes. Now in order to remember all these formulas without having a confusion, I have a quick hack. So suppose you are applying the brake on the front wheels. First of all, the most basic term, that is this thing, Wx cos theta divided by B minus mu H, will come for the front wheel, not for the rear wheel, because you are applying brake on the front wheel. So the basic term will come for front wheel, that is this one. Now you can see that when compared with these two cases, here in the denominator you have B minus mu H. Look, in every term you have a B minus mu H, but here in the rear brake case you have B plus mu H for each of these three terms. So in order to eliminate the confusion of these two things, B minus mu H and B plus mu H, remember that when the rear brake is applied on the front wheels, the front wheel has to endure much more force, because it is placed at the front of the vehicle. That's why it will take all the shock. So that's why the reaction force in the front wheel will be larger compared to these two cases. Okay, so that's why in order to make this term larger, you need to lessen this term, this denominator, that is B minus mu H. That's why you get a B minus mu H. So I hope this will eliminate the confusion between these two things. Okay, for rear wheel case and front wheel case. Okay, now for the rear wheel simply, if you want to get the reaction force for rear wheels, simply subtract this term, that is RA, from W cos theta and take the W cos theta common, and this will result in this way. Okay, so there is a similarity you will find. Now for F by G, there you can see that there is no W, or there is no weight involved. See clearly, but instead of W, here a mu comes. So mu X cos theta divided by B minus mu H minus sin theta, that will give you the F by G value, or alpha by G value. Okay, now come to the rear brake part. Here, since the brake is applied on the rear wheel first, that's why you get the basic term or the basic formula for rear wheel, that is this one, W into B minus X into cos theta divided by B plus mu H. Okay, now in similar manner you can find out RF just by subtracting this term RR from W cos theta, that is the total force, that is, so which will give you W cos theta into 1 minus B minus X divided by B plus mu H. Okay, and for F by G value, again don't write W there, but replace the W with the mu, and this one will be same, that is B minus X into cos theta divided by B plus mu H, and just like the previous one, give a minus sin theta. Okay, so now for both wheel case, this whole scenario will be different. In the denominator part, there will not be any mu plus mu H, and when you get the rear wheel reaction force, you just subtract this thing from W cos theta and you will get this. And for F by G, this is the most easiest one to remember, that is mu cos theta minus sin theta. Okay, so remember there is one similarity, that minus sin theta will be in each of these three values, for in case for front wheels, for rear wheels, and for both the wheels. Okay, so I hope this will clear the any confusion or doubt for this braking action. So if you like this video, do subscribe my channel, like the video, comment if I did any mistake, or if you think that I can add some more value to this video. Okay, or if you have any suggestion, then please comment and subscribe my channel, and if you want some other content, then comment and let me know what you want.